These teachers Joseph from Brainstem Academy, and today we will look at Cambridge IGCSE for Chemistry Paper 2, multiple choice extended for May-June 2025, okay, Paper 2, Variant 2, 0620. Question 1. An ice cube melts. What happens to the molecules of water in the ice cube? So melting involves bond breaking. For bond breaking to happen, to allow the particles in a solid state to convert to the liquid state, the particles must gain energy. It is an endothermic process. Evaporation refers to liquid turned into gas, all right? And basically over a range of temperatures. Dissolving means from the solute dissolved in a particular solvent. Popular example is water, turning it into an aqueous solution. And then losing energy is for bond formation processes, which is not happening for this case. Question 2. A sample of a liquid X is heated to a temperature above its boiling point. X is then cooled so that it condenses and then freezes. Which graph describes the change in temperature of X over time? Now, so given that it is heated from a temperature lower than the boiling point, and during boiling, or should I say during any state changes, for example, condensation and also freezing, temperature actually remains unchanged. During boiling, during freezing, and during condensation. So we should expect to see three horizontal lines, given that this is a temperature time graph. So from here, actually, we do see everything here has horizontal lines. So we can look at other points instead. So it is heated to above its boiling point. So we should expect to see a slanted line going upwards, horizontal, followed by another slanted line because this is the boiling point. And then it's cold. When it's cold, this temperature will begin to drop, and then followed by condensation happening. Now, the boiling point and the condensation point are actually of the same value. So we should expect to see these two horizontal lines at the same, having the same Y value. Then this chemical is dropped down further to its freezing point. So most likely it will be going even below than the original temperature because, well, if this chemical is found at its freezing point, it would have been frozen, right? It would have been found in solid form. So it's liquid. That means this temperature must be between the melting point and the boiling point. So therefore, this graph is followed by a horizontal line. So the answer is D donkey. Let's verify that once again. So starting with this be the boiling point, or what we call the condensation point. Then this horizontal value is our freezing point. So first, the chemical is found in liquid state because this temperature is in between the boiling point and the freezing point. Then you heat the chemical to its boiling point, it begins to boil, all right? And then it will start to turn into 100% gases. Then you heat it further. So until it reaches a particular temperature, we begin to cool it down. It will begin to condense, and the condensation point and the boiling point are the same. So you cool it down further, this temperature will begin to drop until it reaches a certain point at which freezing happens. And this temperature must be below our original temperature. So the answer for this question is D for donkey. Next question. Which role gives the number of protons, electrons, and neutrons in an atom of zinc? According to the periodic table, the nuclear number of zinc is 65, and the proton number of zinc is 30. So it has 30 protons, which we can read it from the atomic number. And then we can find out the number of neutrons because the nuclear number is the sum of protons and neutrons. These two are found in the nucleus. So since the number of protons and neutrons equates to 65. So neutrons must be 65 minus 30. That gives us back 35. And since this is an atom, which means there's no charge for this chemical, so the number of protons and electrons must be equal to each other. Therefore, the answer will be A. The same number of electrons and protons are found, whereas neutrons can be found by taking the neutron number minus the proton number. Question 4. Which particles have the electronic configuration of 288? First of all, argon has 18 electrons, so it's arranged in 288. For ions, it's better for us to find the atoms, number of electrons, and electron arrangement first. So based on the periodic table, aluminium is a particle with 13 protons, sodium has 11 protons, and chlorine has 17 protons. So therefore, the electron arrangement will be 283, 281, and 287. When they form ions, they will try to achieve a noble gas electronic configuration. So the closest value that they can achieve are respectively 28 for our aluminium ion, 28 for our sodium ion as well, and 288 for our chloride ion. So from here we see that only two options have the electron arrangement of 288. So therefore the answer is B for boy. Question 5. A sample of element Q has two isotopes. Their relative masses and abundances are shown. What is the relative atomic mass of this sample of Q to three significant figures? To find the relative atomic mass, also known as AR, it is basically the average of the relative isotopic masses. So to find the average of the relative isotopic masses, what we do is we take 238 multiplied by 66, given that this is like the frequency, and sum them up together with 244 multiplied by 34, divided by total frequency. So total frequency is these two values added up to each other, sum them up together. So by using your calculator, we should be able to find out that the numerator is 24004. So after calculation and adjusted to three significant figures, this value is 240. So the answer is A. Question 6. Which statement about silicon 4 oxide is correct? Silicon 4 oxide is a giant covalent structure containing silicon covalently bonded to each silicon atom covalently bonded to 4 oxygen atoms, while each oxygen atom is covalently bonded to 2 silicon atoms. And this structure keeps on repeating, forming a giant covalent structure. So it's not a simple covalent molecule. And given that this giant covalent structure, there's no free moving electrons, so it cannot conduct electricity. So the answer is B for boy. It is a giant covalent structure with each silicon atom bonded to 4 oxygen atoms. Its structure is not similar to graphite because graphite is having a hexagonal structure, having multiple layers of hexagonal structures that is bonded to each other via weak intermolecular forces. Whereas our silicon 4 oxide is having a tetrahedral structure, at least around the silicon atoms, right? This tetrahedral structure. Next, when 65 grams reacts with 32 grams of sulfur, 97 grams of zinc sulfide is produced. When 65 grams of zinc react with 40 grams of sulfur, the mass of zinc sulfide produced is still 97 grams. Which statement explains this observation? Now, so the idea is the reason why the excess sulfur, okay, we can see that this is in excess, doesn't react further is because that's all the zinc has reacted. In other words, zinc is the limiting reactant. There's not enough zinc to react with the remaining 8 grams of sulfur. It's already used up. So the answer is D for donkey. Next, aluminium reacts with iron trioxide to form aluminium oxide and iron. Which chemical equation for the reaction between aluminium and iron trioxide is correct? Now, iron trioxide, to construct the chemical formula, we must know the oxidation numbers of the ions. And that gives us Fe2O3 by doing this swapping method. This is how we find ionic formula. Same goes with aluminium, which has a 3 plus charge, and oxide having O2 minus formula. So we get Al2O3. So these are the correct formula for these two chemicals. So we can actually cancel out our answers for A and B. And then the answer is D for donkey because of balancing. So to have 2 aluminium in our aluminium oxide, we must have 2 aluminium instead of 1. Number 9. The concentration of a solution of aqueous sodium hydroxide is 0.50 mole per cubic decimeters. Which mass of sodium hydroxide is used to make 500 cubic centimeter of this solution? Now, in general, if we are given a particular amount, or should I say value for a particular chemical, in order to convert this to a completely different amount in, or should I say a different unit, so what we need, okay, they are asking us for mass here. What we need to do before we can do that is to actually convert this to moles first. We must find the number of moles of this sodium hydroxide. So what we can do is, to convert concentration to mole, we have to multiply by volume. So taking this, multiply by volume, concentration times volume. Make sure you convert this to cubic decimeters, which is by dividing by 1,000. Then the units can cancel, which gives us 0.25 moles. So using this, how do we find mass from moles? We can multiply by molar mass. To find molar mass, we need to use the periodic table and look at the mass values of the elements. So sodium hydroxide, based on the periodic table, the relative mass is 23 for sodium, 16 for oxygen, and hydrogen is 1. That totals up to 40. So using 0.25 mole multiplied by 40 grams per mole, that actually gives us 10 grams. Next, molten zinc oxide is electrolyzed using inert electrodes. Which row identifies the product at each electrode? Now, given that this is molten, the electrolysis will be quite straightforward, in which you will get your metal at the cathode and non-metal at the anode. So we will be getting our zinc from zinc ions here and oxygen from oxide ions. The half equations will be, oops, my bad. I've marked the wrong answer, but the answer is oxygen at the anode and zinc at the cathode. So the half equations at the anode will be our oxide ions getting oxidized to form oxygen gas, and our cathode will be having the half equation of the zinc ions getting reduced to form zinc metal. Next, dilute aqueous sodium chloride is electrolyzed using platinum electrodes. What is the half equation for the reaction at the cathode? Now, at the cathode, reduction happens. So from here, we can actually eliminate answers for C and D. It's either B or A. Now, at the cathode, or should I say in this solution, there are a total of 4 ions. 2 coming from the solute, which is sodium chloride, and then 1 coming from the solvent, which is your water in the aqueous solution. They produce hydrogen ions and hydroxide ions. Now, the cathode being a negative terminal attracts the positive ions. So only one of them will get discharged. In this case, it will be our hydrogen that gets discharged, because sodium is more reactive than our hydrogen. Or should I say, hydrogen is easier to get discharged compared to sodium. That's why we get hydrogen, not sodium. Next question. hydrogen-oxygen fuel cells can be used to power vehicles. Which statement about hydrogen-oxygen fuel cells is correct? So first, hydrogen-oxygen fuel cell is about these two chemicals react each other to form just water, and in the process, release a lot of energy. So the benefit of this is that it doesn't form any carbon dioxide. And we are utilizing the chemicals' energy and turn them into actual electrical energy so that the engine can run. So hydrogen is not a fossil fuel. Instead, fossil fuels in IG syllabus, we focus on mainly three, which is coal, petroleum, which is also known as crude oil, as well as natural gases. So hydrogen is not technically a fossil fuel. The answer is C. Next, a reaction pathway diagram is shown below. Which row identifies the type of reaction and how the temperature of the surroundings changes during this reaction? Now, given that products have more energy than the reactants, it means that overall, reactants have to absorb energy so that they can get to a higher energy state in the products. Therefore, it must be endothermic. And as we know, endothermic reactions involve a decrease in the temperature of the surrounding because the chemicals will take in energy from the surrounding, causing a sharp decline in the temperature recorded, or should I say temperature of the surrounding. Next, the average bond energy for the CH bond is 413 kilojoules per mole. What is the enthalpy change when 1 mole of methane molecules is formed from carbon and hydrogen atoms? So carbon and hydrogen atoms, together they react and form methane. So the enthalpy change follows the formula of bond breaking minus bond formation. Right, energy used in bond breaking minus the energy released from bond formation. Now, since these particles in a reactant site are already atoms, we don't have to do any forms of bond breaking here. Whereas, let's just do bond formation. This CH4 looks like this. So each bond energy is 413. So the total bond energy involved in bond formation is a total of 1652. So using the formula, 0 minus 1652 equates to negative 1652. So the answer is A. Next, question 15. Which statement describes the effect of adding a catalyst to a chemical reaction? Now, first of all, a catalyst helps us to decrease activation energy of chemical reactions. So after adding a catalyst, we should expect to see the activation energy to be lowered instead of increased. Then, however, as you can see, the net energy change, or should I say enthalpy change, actually do not change. So the answer is B for both. This is true. Now, catalyst doesn't actually affect the frequency of collisions. Instead, it affects the frequency of successful collisions as they make it easier for the particles to react by having a lower activation energy. Catalyst actually doesn't affect kinetic energy. Instead, the factor that affects kinetic energy is temperature, not catalyst. So the answer is B for both. Next, question 16. Which role describes the conditions used in the manufacture of sulfuric acid by the contact process? So the answer here is vanadium 5 oxide with 450 degrees Celsius and 2 atm, which is, the answer is C, a high temperature and a low pressure. Next. Wait, sorry. I misread the question, sorry. 450 degrees Celsius, high temperature, and 2 atm, vanadium 5 oxide. Okay, 17. Which equations show The underlying species acting as a reducing agent. So a reducing agent is a substance that undergoes oxidation by reducing others. So we just need to find out who undergoes oxidation in this scenario. So not one, because our iron trioxide just lost oxygen. Then 2, our iron goes from 0 to +2 in terms of oxidation numbers. So 2 is indeed an oxidation process. And then from 3, we see that our iron 2 goes to become iron 3, which is +2 to +3. So we also see that this is an oxidation reaction. The answer is 2 and 3. Whereas for our question 4, iron is +2 here. Here, this is still +2. So this is not a redox reaction. So the answer is 2 and 3, which we can see the increase in oxidation number of iron. Next, a farmer incorrectly added 2 substances to the soil at the same time. They react together and form a gas which turns damp red litmus paper blue. What are the 2 substances? Now, in IG syllabus, there's only one alkali gas, that being ammonia gas, which is an alkali gas that can turn red litmus paper blue. In order for this to happen, we need to use ammonium, which reacts with alkali. This forms ammonia and water. The reason this happens is because ammonium is actually an acid. And acid reacts with alkali. So that's how we form ammonia gas. So for the other options, I would say that A, there's no reaction. B will be the answer, base and ammonium. C, not gonna form ammonia. And D, no reaction, because both are acids. So the answer is B. 19. Which row shows the equation for the dissociation of hydrochloric acid and of ethanoic acid in the aqueous solution? Now, hydrochloric acid is a strong acid, whereas ethanoic acid is a weak acid. So strong acids will fully dissociate instead of having partial dissociation. So it's represented with a one-way arrow in its dissociation equation. Whereas for our weak acids, we need to put a reversible symbol to show the partial dissociation process. So the answer is A. 20. Which 3 oxides are all acidic? Acidic oxides normally are non-metal oxides. So all we have to do is figure out which elements are non-metals. So the answer is C. Carbon, nitrogen, and sulfur are non-metals, so their oxides are acidic. Next, the table shows some properties of noble gases. Which row predicts the density and the boiling point of krypton? Now, as we can see going down, the density of the chemical of the noble gases actually increases. Whereas we see that the boiling point is also increasing as it is heading towards a less negative scale. Right? If you draw a scale, temperature scale, it actually involves an increase in the boiling point. So boiling point also increases. So we just have to find values that fit this pattern. That being C, which is 3.8 and -153. Next, sodium is a group 1 metal. What is a physical property of sodium? Now, sodium is a metal. So it must be able to conduct electricity. And it should be malleable. Although most metals have high boiling point and melting point, group 1 are exceptions for this group. They have low melting point and low density instead. Next, tennessine, atomic number 117, is a manufactured element that is below astatine in group 7 of the periodic table. What is the expected state of tennessine at room temperature and pressure? Now, going down our group 7, the melting point and boiling point increases. As we can see from the chemical examples like fluorine, chlorine, bromine, iodine, tennessine. So we should expect to see that these chemicals will be diatomic, as well as the state will be gradually changing from gas to liquid to solid. So tennessine is most likely a solid at room temperature and pressure. Based on the trend here. Moving forward, 24. When chlorine is bubbled to aqueous sodium bromide, a displacement reaction occurs. Which description of this reaction is correct? Now, the reason why this reaction can happen is because chlorine is more reactive than bromine, where a displacement reaction happens, forming these two products. So it is our chlorine that displaces the bromine. The answer is B for boy. In terms of the language, we usually just refer back to the original elements instead of calling the ion names. That's why the other options are invalid. Next, 25. Brass is an alloy of copper. Which statement about brass and copper is correct? Brass actually conducts electricity because ultimately it is a mixture of copper and zinc. So copper conducts electricity because its electrons are free to move, not atoms. Brass is harder than copper because its layer of atoms cannot easily set over each other. That's correct. That is why alloys are commonly used in production, in construction industries, because of it's stronger and harder as the layer of particles cannot slide past each other, as you can see for the diagram here. So copper is not stronger than brass because for metals in their pure state, they are malleable and ductile. In other words, they are easily bent because normally these particles that have the same size, it's easier for them to slide past each other, for the layers to slide past each other. So 25, the answer is C. Let's go to 26. The ionic equations for some reactions between metals and aqueous metal ions are shown. Which further information can be used to place copper, magnesium, silver, tin, and zinc in order of their reactivity? Okay, from the information, basically the tip is the metal that turns into the ion will be the one that is more reactive. Because being ions means that they turn into they are reacted with a compound. So the one that turns into an ion is more reactive. So from here, we can see that based on each equation, copper is more reactive than silver. Second shows you that magnesium is more reactive than zinc. Third shows you that zinc is more reactive than copper. And the fourth equation tells you that tin is more reactive than copper. Now, from the list here, we know that copper is more reactive than silver, and our magnesium is more reactive than zinc. But for tin, it is not so clear. We know that it's somewhere here, but we don't know, is it more reactive than magnesium or zinc or just copper? So in order to be able to place our tin here, we need another information, that is, if zinc reacts with tin 2, it means that zinc is more reactive than tin. That's how we can place our tin here, which is less reactive than zinc, but more reactive than copper. So we are lacking information from A. Next, zinc is used to galvanize iron to prevent it from rusting. Which statements are correct? Well, first, steel in real life are commonly galvanized, which is you put a layer of zinc around the steel. Now, zinc galvanizing is actually a double protection method because, first of all, it is basically a barrier to prevent oxygen and water from getting into contact with the iron inside. So yes, it is a barrier method. Now, the double benefit of this process is that even when the zinc layer is scratched, when this happens, this iron still doesn't rust immediately. So for 2, it's wrong. It will not rust that quickly because zinc is more reactive than iron. And in this case, actually, it does a second function. That is, it will corrode in preference to iron. It will basically sacrifice itself to protect iron from rusting. So it will still somewhat protect the iron from rusting, even when the iron is exposed to the water and oxygen from the outside. So for 4, it's wrong because although yes, zinc is more reactive than iron, however, it's not about accepting electron. It's about donating electrons. So the answer is B for what? Next, which equation represents a reaction that occurs in a blast furnace during the extraction of iron from hematite? Well, there's a total of 5 equations for this process. And the only one that is in the equation, in the 5 equations, is D for Dr. So the whole process goes like this. First, we have calcium carbonate, which is limestone thrown in. It thermally decomposes to calcium oxide and carbon dioxide. This calcium oxide will react further with silicon dioxide to form calcium silicate, also known as slag. So the purpose of this is to remove the impurity from the hematite. Then, coke is added so that it provides energy as well as produces carbon monoxide via a 2-step process. So this carbon monoxide is a strong reducing agent which helps us to reduce iron back to its elemental state. So these are the 5 equations we must know for the blast furnace, and the others are invalid. They don't occur in the blast furnace. 29. Water is added separately to anhydrous copper 2 sulfate and anhydrous cobalt 2 chloride. Which row shows the color changes? Well, this is a straightforward question. This chemical is originally white. When there's water, it turns blue. For our anhydrous cobalt 2 chloride, originally is blue, but then it turns pink. That's all. Straightforward question. Next, 30. Gases which cause acid rain form in car engines. These gases can be removed using a catalytic converter. Which equation represents the removal of one of these gases using a catalytic converter? Now, the idea of a catalytic converter is that it helps us to remove harmful gases and turn them into slightly less harmful gases via redox methods, catalyzes redox reactions. So the answer here is B, because we can see that A, C, and D produce pollutants, but not for B. In fact, B is a popular equation that happens in the catalytic converter, which is carbon monoxide and nitrogen monoxide. They react with each other via redox and turn into slightly less harmful emissions, nitrogen and carbon dioxide. Next, which statement about carbon dioxide is correct? So first, carbon dioxide is a greenhouse gas, so it does absorb thermal energy from the earth, which then prevents, or should I say reduce, the loss of thermal energy to space. So 2 is wrong, not increase, but to reduce. This causes global warming. However, carbon dioxide is not the only gas. There are other gases like methane and also water vapor that does the same thing. These are all greenhouse gases. Whereas this problem is getting more serious because of burning of fossil fuels. So the answer is 1 and 2. Next, what is the structural formula for butane 2O? Now, for butane 2O, the hydroxyl group is located on the second carbon. So for our first answer, this is propane 1O. It only has 3 carbon. And this one at the ending, the first carbon. This is propane 2O. OH is at the second carbon. The answer is C. No. Sorry. The answer is D. This is butane 1O. As you can see, the OH is on the first carbon. And the answer is D for donkey, where the OH can be found on the second carbon. And there's 4 carbon. Okay, next. Methanol reacts with ethanoic acid to form an ester. What is the discrete formula for this ester? Well, that will be forming a methyl ethanoate. So how it forms is, first we have methyl. When these two chemicals react with each other, it's a condensation reaction in which water, H2O, will be removed, and these two structures connect to each other. So this is our methyl ethanoate. Oops, sorry, did I make a mistake? Yeah, I made a mistake, sorry. This is propanoate, sorry. Again. So I put a H here, we put a H here. Okay, once again. So ethanoic acid with methanol react with each other. So remove water, join together. So this is what the structure is at the end. So the answer here is C. It's just the same thing but flip around. Methyl, CH3, and 2 carbon with the ethanoic structure. 34. Petroleum can be separated into useful fractions by fractional distillation. Which row shows a correct use of name fraction? Now, bitumen is used to make roads. Naphtha is a chemical feedstock. It's used to make other chemicals. Kerosene is used in jet fuel. That's correct. Refinery gas is for home heating and also cooking. So the answer is C. 35. Ethane reacts with chlorine in the presence of UV light. Which products are formed? Now, this is called UV light halogenic substitution. In this process, for example, let's say we react these two together, it will form a chloroalkane. All right, chloroalkane. Then it will form a byproduct like hydrogen chloride. This process actually doesn't form hydrogen gas. If you look back, it never forms hydrogen gas. It only forms hydrogen halides. So since we're using ethane, it's going to form chloroethane instead. This process doesn't form alkenes. To form alkenes, we have to go for a different process called cracking. So the answer is C. Next, ethanol can be made by the fermentation of aqueous glucose and by the catalytic addition of steam to ethene. What are the two advantages of making ethanol with catalytic addition of steam to ethene rather than by the fermentation of aqueous glucose? Well, this is how catalytic addition of steam occurs for our ethene. Now, this process, actually, ethene is not renewable because to get ethene, we have to do cracking of alkanes, and alkanes are gathered from fossil fuels. Okay, from the fractional distillation of fossil fuels like petroleum. So it's not very renewable. Now, however, this process is very pure and very fast because it's carried out at high temperature and also pressure. So the resource here is not very renewable, and using more energy is not an advantage. The answer is B. Next, the structure of a polymer repeat unit is shown below. Which pair of monomers is used to make this polymer? Now, first of all, we can see that this is a polyamide. because it has this functional group, which is amide linkage, CONH. That's our functional group. To form an amide, normally in IG syllabus, we focus on using carboxylic acids and also another functional group, or should I say homologous series, called amines. Right? And according to the structure here, we see that the diamine has 2 carbon, and the dicarboxylic acid has 4 carbon in total, but then the central structure only has 2 carbon here. So the answer cannot be C or D because they already exceeded the structure here, only 2 carbon. So it must be B for boy, where you can see based on the highlight that this part originates from here, and then the functional group is made from this part, this part. So this is a condensation polymer, where as you can see, once we remove water, these two can form amide linkage, CONH. So the answer is B for boy. Next, which item of apparatus is used to measure exactly 26.3 cubic centimeters of a liquid? Now, first of all, this is a liquid. We cannot use the gas range. Then we cannot use a pipette, a volumetric pipette, because a volumetric pipette can only measure fixed volumes. But for example, 25. If you take a 25 cubic centimeter pipette, it can only measure 25, not 26.3. The answer also cannot be D, because measuring cylinder is not that accurate. So to measure exactly this amount, we can use a burette, which is more accurate than a measuring cylinder. Next, a mixture containing an aqueous salt and an insoluble salt is filtered. Which row describes X and Y? This is a straightforward question. The top of the filter funnel, the solid that remains here, is known as the residue. The solution at the bottom, after filtration, is known as a filtrate. So this is a straightforward question. Last question. Pure ethanol has a melting point of negative 114 degrees Celsius and a boiling point of 78 degrees Celsius. What are the melting and boiling points of a sample of ethanol with glucose dissolved in it? Now, our ethanol now has some impurities inside. When there's impurities inside our solvent, in general, the melting point will begin to drop and the boiling point will begin to increase. Okay, when there's impurities. So, therefore, the melting point should be lower than negative 114, which will be negative 116, and our boiling point will now be greater than 78, which is 79. The answer is B for boy. Okay, so if you are struggling in IG chemistry and you need tutoring assistance, our team will be able to help you in the subject. All right, so if you need help for any papers, or should I say any chapters, do contact us and then we will provide you the details. We offer weekly lessons as well as online modules for you to catch up. All right, so that's all, and hope to see you in the next video.